Alright, so we've already graphed sine and cosine, so now it's time to look at the graphs of the other trigonometric functions. In part 1, we're just going to do tangent and cotangent. So we'll start off with tangent, what the table looks like, what the graph looks like, and then some facts about it. Then we'll repeat the process with cotangent because they're really close. So the tangent function, which is these values down here at the bottom, come from taking the sine and dividing by cosine, or x divided by y in the unit circle. Some of the key values that you're going to want to remember is that tangent is 0 at 0 degrees, and it's undefined at 90 degrees, so that's 0 radians and pi over 2. As we go this way, through the other values, tangent is increasing. So let's look at it a little bit more in depth by looking at the graph. So we're going to go through a whole cycle of 2 pi, which makes sense for sine and cosine, but it's not actually going to be, it's going to be a little bit different for tangent. So let's just start here. At 0, we have 0. I'm going to spread myself out, make this 1 and this negative 1, okay? So I'm starting here at 0, 0. These values here, or, at least the pi over 6, I'm not quite sure where that is, but I do know where 1 is. So you could graph a little bit more precisely by figuring out what 1 over root 3 is, but I'm just going to try to get the bare bones here. Okay, so then I've gotten that one. Again, with pi over 3, not exactly sure where we are. But at pi over 2, we're undefined. That's going to give us a vertical asymptote. So at pi, we're back at 0. At root 3 over 2, we are back at undefined. And at 2 pi, we're back at 0. So far we have a graph that's starting to look like this. We need to fill in some more values here. Going backwards, as I go through, like let's say negative pi over 4, I'm going to be at negative 1. And at negative pi over 2, I'd have another vertical asymptote. And so then I would start repeating this process. We've now seen a full period of tangent. So these 2 points are going to repeat, just shifted down. And the pattern continues. So that's what the tangent graph looks like when you sketch it. Here's a better version of it, nice computer generated. So let's remind ourselves some of the facts here that we can find from reading the graph. If we look at the domain, we notice that there are some x values that are undefined. So usually when we talk about the domain of tangent, we say that it's all except all except odd multiples of pi over 2. So that's pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2, negative 5 pi over 2. The range is nicer though, that's all real values. We would only say that tangent is continuous when we look at the domain. So we would say it's continuous over its domain. Seems like cheating to me. It's always increasing. There's never a point when the graph starts going from a high value down to a low value. It jumps, but it doesn't decrease at any point. It is symmetrical with the origin. So it's an odd function. And it has vertical asymptotes at the same place that we talked about in our domain, odd multiples of pi over 2. So that's it for tangent. So let's start looking at cotangent. Now we're at the bottom of this table. Cotangent is going to be cosine divided by sine, so we're looking at the inverse, or sorry, the reciprocals here. So this time we're at undefined at 0, and we're at 0 at pi over 2. These values are going down as we go across the table. So when we graph this, I'm going to just add in the values down here at the bottom. We're looking at cotangent. At 0, we're undefined. At pi over 6, we're going to be at a higher value. We're going to be at the root 3. We're still at 1 at pi over 4, but then we go to the 1 over root 3. Then we get to 0, and this is where they're reversed of each other. So that means tangent's going to have a lot of similarities, but just a little bit different, and it's different enough to really throw people, so be careful. This time I have my asymptotes at pi and 0, and at 2 pi. I'm going to hit 1 at pi over 4. And I'm going to hit 0 when I get to pi over 2. So that means that I would hit -1 down here. So cotangent looks like this. Looks like that. So some quick facts. The domain is, for tangent, similar. We have some domain restrictions here. We will have, the domain will be all except multiples of pi. Pi, 2 pi, 3 pi, -5 pi, etc. All real values. It's continuous over its domain. This time it's always decreasing. It has no symmetry. And its asymptotes are at multiples of pi. Alright, so that's the basics.